This video is for the multiplying polynomial functions foldable. So on this set of notes, we're going to do it mathematically, and then we're going to look at a real-world situation. All right, so number one, given the functions f of x equals 3x squared plus 6x minus 30, and g of x equals 4x plus 5, we're going to use a table to determine the dependent values of f of x and g of x, and then we're going to use these values to find the value of h of x, where h of x equals f of x times g of x. So just like we did with the addition and the subtraction, we can go into graph and we can put our function. So we've got 3x squared plus 6x minus 30, and we can pull up the table. And go to where x is negative 2, and then we can fill these values in from the table. So we've got negative 30, negative 33, negative 30 again, negative 21, and then we've got negative 6. Okay, and then we can do the same for g of x. So we can get out of this table and type our next function in. So 4x plus 5, pull up the table, go to where x is negative 2, so we've got negative 3, 1, 5, 9, and 13. And then what we can do is we can multiply these two numbers together. So we can do negative 33 times 1, which gives us a negative 33, negative 30 times 5, which gives us negative 150, negative 21 times 9, which gives us negative 189, and then negative 6 times 13, which gives us negative 78. Okay, so we know that h of x should equal these values when x is one of these values. So we can also use a symbolic representation to do this. So we can multiply the two functions together. So 3x squared plus 6x minus 30 times 4x plus 5. And so to multiply those out, I'm actually going to flip them around. I'm going to do 4x plus 5 and then times 3x squared plus 6x minus 30. So what we do is we distribute. So we distribute the first term. So 4 times 3 is 12. X times x squared is x cubed. 4 times 6 is 24. X times x is x squared. And then 5 times negative 30 is a negative 150. And then I can do the same thing. I can distribute the 5 across all three terms. So 5 times 3 is 15. And then it's going to be an x squared. So I'm just going to go ahead and line it up here with the other x squared. 5 times 6x is a positive 30x. So I'm going to stick that one down here, positive 30x, and you'll see why in a second. And then 5 times a negative 30, I'm off somewhere, 4x, that's where I'm off, okay. 4 times negative 30, that's the one I did wrong. So, let's look at that. So 4 times negative 30 is negative 120. This should have been negative 120, and then with the x attached, then we can put the plus 30x here, and then finally 5 times negative 130 is negative 150. So I'm sorry, no, that's hard to see. That's a negative 120 there. But when I do it this way and I stack up, it makes it a lot easier to combine like terms. So there's no other x cubes. 24 plus 15 is 29, x squared. Negative 120 plus a 30 is negative 90, keep the x, and then minus 150. So that is, when we multiply those two functions together, that's the symbolic or the algebraic representation of the new function. Okay. And so what we can do, we can take that function, 12x cubed plus 29x squared minus 90x minus 150. I could take that, and everywhere that I see an x, I could plug in the x value that I need. What I'm going to do is I'm just going to plug that function just like we did. Ooh, sorry. Try that again. Into my graph. So 12x cubed plus 29x squared minus 90x minus 150. And then I can pull up the table. Okay, so we're looking for -2. Let me still off here. Okay, so I apologize, guys. That should be, maybe, this should be a 39. And then pull up the table. So this should be a 39, and then over here, that should be a 39 as well. I did not add correctly. Okay, so when x is -2, h of x is 90. When it's -1, h of x is -33. When it's 0, it's -150. 1, -189, and 2, -78. So they match up. It's the same values. So using both representations, the product of the dependent values, or y values, of h of x equals f of x times g of x is equivalent to the evaluation of the independent values, or x values, of the combined function h of x equals 12x cubed plus 39x squared minus 90x minus 150. Okay, so now looking at a real-world situation. We've got a rectangular prism, and it says, what is the formula for finding the volume of a rectangular prism? Well, that's V equals big BH. Big B is the area of the base. So the area of the base we're going to find by multiplying the length times the width. So you probably are used to the formula volume equals length times width times height. But formula charts now listed as big BH. So if we look at this, the width is x, the height is x plus 4, and the length is 3x. So we're going to write a simplified function for the volume. So we're going to multiply those three measurements together. So we're going to do x, so I'm going to knock out the easy ones first. X times 3x, and then we're going to multiply that by x times 4. So x times 3x is 3x squared. And then I'm going to multiply 3x squared by x times 4. So 3x squared times x is 3x cubed. 3x squared times 4 is 12x squared. And so I have v of x equals 3x cubed plus 12x squared. Sorry guys, that keeps going in and out of focus. Okay, so now what we can do is we can complete this table here. So if x is these values, we want to find what the width would be. Well, the width is x. So if x is a 1, then the width is going to be a 1. Okay, if x is 2, the width is 2. If x is 3, the width is 3. And if x is 4, the width is 4. So h of x, we're adding 4 to x. So if x is 1, then the width, or the height, the height, just a second. So the height would be 5. If x is 2, the height would be 6. If x was 3, the height would be 7. And if the x was 4, the height would be 8. And then for the length, we're just going to multiply the x by 3. So we would have 3, 6, 9, and then this one would be 12. So v of x, the volume, is multiplying all three of these together. Okay? So 1 times 5 times 3 is 15. 2 times 6 times 6 is 72. And then we've got, let's see here, 3. Let's get to the calculator page. 2 times 6 times 6 is 72. 3 times 7 times 9 is 189. And then 4 times 8 times 12 is 384. Or we could use that function we created. The 3x cubed plus 12x squared. Again, we could plug and chug. I'm just going to stick it in the graph. So 3x cubed plus 12x squared. Pull up the table. And then we've got our values. And you can see again, just like in our other tables, everything matches up nice and neat.